Good evening, students. I'll start with the class. I'll start with the new chapter, that is gravitation. Till now, we were studying this. We came across this word called gravity or acceleration due to gravity. Okay. There's a difference between gravity and gravitation. So, what is What is the difference? Is gravity is nothing but we know that it is related to the Earth. Any object sits there, what will happen? It will come towards the ground. Any object you throw in the sky, definitely it will come back to the ground. Why? Because there's a force, okay, which the earth is trying to exert on this and trying to pull it towards itself. So that is called as a gravity, the force applied by the earth on the object. Now what is this gravitation? So gravity is related to the earth. Now gravitation means how earth exerts force, no? Same way any body in the universe, okay, or even like two planets, you can say, other than earth also, like Jupiter and Saturn. Among them also there's some kind of force of attraction between them. So if their mass is different mass, m1 and m2, and you have certain distance between them, okay, there will always be some force which will be exerted on each other. So that force is called as gravitation. Okay, and that force formula is given as G times m1 m2. This I will give you, no need to write, upon r square. This force depends on the mass of the objects and also depends on the radius or the distance. This r will be the distance now. Distance between the two objects. So lesser this, like if the distance is very small, force will be big. If force is they are very far away, then force will be small. It's like basically dividing by a small number. So if r was supposed 2, so this would give you 4. So anything divided by 4, okay, and comparatively, suppose if distance was 10, so 10 square would give you 100. So any number divided by 100 will make the number small. So here what will happen? Force will be big, and here force will be small. So what basically it means, larger the distance, smaller will be the force. Okay, and it depends on the mass also of the object. Now what is this G? G will be called as a gravitational constant. So there's a difference between capital G and small g. This is gravitational constant, and the small g is acceleration due to gravity. So I'll give the definitions. First I'll tell you what is gravity. So you know that gravity is nothing but a force of attraction exerted by the earth on a body. What is this acceleration due to gravity we speak about? It's nothing but acceleration produced in the motion of the body, in the motion of a body under the effect of gravity. Basically, what it means, when you have a tree, suppose there's a fruit which is falling, so obviously the fruit which is falling will start accelerating. Why is it accelerating? Because there's a force which is being pulling it towards the ground. Okay, so under that effect of gravity, this force, so whatever is the acceleration produced in the motion of that fruit which is falling down, so this acceleration is nothing but called as acceleration due to gravity. Why is it coming down? Because it's accelerating because gravity is pulling it. So that acceleration caused because of gravity is called as acceleration due to gravity. That letter will be small g. Now what is gravitation? Gravitation is nothing but it is the force of attraction between any two bodies in the universe. So not necessary it has to be Earth. It could be between Earth and Moon also, between Moon and the other planets. And gravity is only with reference to Earth. Now, based on this, as Newton's law of gravitation, now I told you this formula, force is nothing but G times m1 m2 upon r square. Whenever anything force, suppose if the G was not a constant, if this sign is there, is directly proportional. This word is called as directly proportional. If anything is in the numerator, if both are there in the same line, this it is called as directly proportional. We have already studied it. And if something is there in the denominator, it means it is called as inversely proportional. So this is m1 m2 and it is called directly proportional. And so this is what r square. So it's reverse, reciprocal, no? It's in the denominator 1 upon something. Then it is called as inversely proportional. Okay. So if it's in the numerator, the word used is directly proportional. If the any term is there in the denominator, then it is called as inversely proportional. So based on this, what it is trying to say, force, it states that every body in the universe every other body with a force which is directly proportional If you remember the formula, I can write in your own words, which is directly proportional to what? Multiplication means it is called as product. It is directly proportional to product of their masses and inversely proportional to square of the distance between them. Inversely proportional to square of the distance. R means distance, I told you. Between their centers, you can say. I'll draw the diagram then. Between their centers. Newton's law of gravitation states that every body in the universe attracts every other body with a force which is directly proportional to the product of masses between masses of the two bodies and inversely proportional to the square of distance between them, between their centers. If this is the center, this is the distance r between their centers. This is m1, this is m2. So there's a force on the other side. Consider two bodies of mass m1 and m2 lying at a distance r apart from each other. Then, according to Newton's law of gravitation, the force of attraction between the two bodies is given by. So we are basically writing the formula. Given is, we know that F is directly proportional to m1 and m2 as per the gravitation, this Newton's law of gravitation, and F is inversely proportional to 1 by r. So combining, what we will get, F is proportional to m1 m2 upon r square. Combining both of them, you know that force is dependent on mass also, and force is dependent on the distance also. Now whenever I remove that proportionality sign, we have to always replace it by some constant, either k. Okay, usually we represent k, but since we are doing the gravitation chapter, there's a fixed constant for gravitation. So you can replace, instead of k, you can replace it by a capital G. So remove the proportionality sign, so it gets replaced by some constant. So where G is the Gravitational constant.
Teacher can't see.
I can't see the screen.
Oh, wait. Okay. G is your gravitational constant. Now G is a fixed value. Okay, you cannot change this. Newton meter square per kg square. This is in terms of Newton standard unit. In case if you want to write CGS, normally follow this one. Yeah, I mean, in case of this, then it would be dynes centimeter square per gram square. This is the fixed main one. In case in terms of dynes, then it is gravitational constant is 6.67 into 10 raised to minus 11. Now suppose if mass of both the bodies was 1 kg each, suppose if m1 also was this and m2 also was 1 kg, then we'll see what happens. And distance also will keep it as 1 meter. This will be a special case where let two masses m1 m2 be, sometimes they'll use the word unit masses, 1 unit, also called as, some directly they might say let two unit masses m1 and m2. Let two masses of 1 unit is separated by distance of 1 meter. So what will happen to the formula? Therefore F, we know that is G m1 m2 upon r square. Now we are assuming m1 also to be 1, m2 be also 1, r is also 1. Suppose if all the distance as well as mass is taken as 1, F will be nothing but F will be basically equals to G. If you are taking meter, this can be kg. So gravitational constant is equal to the force of attraction between two unit masses. Here, unit masses means mass of 1 kg each, placed at unit distance apart. Again, unit means 1 meter, and this means 1 kg. Unit distance apart. So this is like a special case. Suppose if you are taking everything 1 kg, then your gravitation constant, okay, gravitational constant is equal to the force of attraction. Now the next two derivations, the important one, acceleration due to gravity at a certain height. So if you are asked to derive acceleration due to gravity when if object is at a certain height. Now draw the diagram. This is the earth. Will be the center of the earth. Can name it as this. And let M be the mass. For earth will use capital letter M. Okay. Then we'll consider two different points. One when this is at here, exactly. This is another mass which is kept on the earth, exactly on the surface of the earth. This is at point A, suppose. Now what I'll do, I'll also take it on top. The same object. We'll see what happens when it is taken, when it is at a height. So the straight line, we'll consider at point B. So mass M. Small m I'm using for the small object. Big earth I'm using capital M mass. And this is your height. And from here to here, this distance is R. Capital R, okay. It is the same object at two different points. First will at A and then at B. This one also will be mass M only. We'll write, consider that earth is a spherical body. So one body. So between the two bodies you have to see. Okay. And body of radius R and mass M. Okay, so we are assuming the anyways earth will be spherical body of radius R and mass M. Then let small m be the mass of small body. This is a small body. Now at two different cases, okay, we are looking at. First at point A we will see. If M is at point A, that is where point A is where on the surface of the earth. Basically what we are calculating, acceleration due to gravity. Then acceleration due to gravity will be on the surface of the earth. Now that small m, no, is like almost negligible compared to the mass of the earth. Okay. So now this is what has gravity over here. It's nothing but a force. Okay. Whenever it's related to earth, we know that it is g, small g. So as per that formula, we have seen what force is nothing but g times m1 m2 upon r square. So now acceleration due to this force will be due to gravity right now. Now this is g, m we are considering anyways big mass. So compared to this mass, no, of earth, this you can just completely ignore, and you can simply take it as m only upon. Now what will be the distance from here to here? We are looking at point A. So distance between this center of this and center of this one. Okay. So these are your two bodies now. So how are we calculating the distance from center of one body to the center of another body? So what happens? This is almost r. This r will be so big that even this is a very small object. So you can imagine this will be in micrometers, very small compared to this kilometers. This will be in thousands of kilometers. So it's like even like a small dot compared to this distance. So this also part we can ignore. So assuming that almost it's all equivalent to this r. Okay. So this full distance we can take r. That is the radius of the from here to here is r. So acceleration due to gravity on the surface of the earth will be g equals to, mark this as equation 1. This is r, capital. Radius, you can simply write and keep radius and mass of small object. Okay, of the small object is negligible. It's almost you can ignore it because it's very small compared to the earth. Compared to the mass and the radius of the earth. So that's why you get this. That another m is gone. And this whole thing is assumed to be r. Distance between the two bodies at point A. Now we'll see at point B. If that small mass is m. M is at point B. That is what where at a height h from the surface of the earth. Height h from the surface of the earth. Then what is acceleration due to gravity? At height h. So which letter we will represent? Both g will be different. This no will look different. So for g, this g will use height at height h. So gh we will see. So g m. Now how much is the distance from here to here? It will be nothing but r plus h the whole square. Total distance from here to point B will be this plus this. So r plus h square. So we'll get equation 2. Now we'll divide both the equations. So we'll divide equation 2 by equation 1. Okay, left hand side upon left hand side, right hand side upon right hand side. Now reverse this. It's like A upon B, C upon D. So this will go and get reversed. Will go and come like this. So what will happen? This will cancel. Now what I want? Gravity at height. At a height. The question itself is you have to find the acceleration due to gravity at a height. So basically this one. So this I don't want. So what will happen? This will go up. So GH I'll keep here this side. And this J I'll take on top. So basically what remains is this is gone. So R square upon. Okay. No. What I'll do is divide numerator and denominator by R square. Because I don't want R the same R square at two different places. So divide numerator and denominator by R square. What I'll get? So if I divide numerator, here it will get cancelled. Now I have to simplify this. So what I'll do is, see, x square upon a square can be written as x upon a the whole square. If both have square, we can always make it common square. So as per that logic, what will happen? This is also square, this is also square. So what I'll do, I'll make it common. Okay, make the square common. Now this r will get divided for both the terms. So r upon r will give me 1. Now this whole term I will take on top. So what will happen? This power will become minus. Now this is now using something called as binomial theorem in maths. That chapter is actually deleted for y'all. Okay, 11th standard. So as per that binomial theorem, now we have to go on expanding this. It becomes a lengthy process. So what we do is we write only the first term of it. So it's nothing but it's like 1 plus x raised to minus 2 is nothing but 1 minus 2 times x. As per the binomial theorem, this is the formula. Okay, so we will not go in detail in the chapter how it works because we'll have to know the entire binomial theorem. Anyways, even in maths, not needed. If at least it was there in the maths, I would have explained the whole thing. That chapter itself is deleted, so you all will not come across only this chapter, binomial theorem. So you can straight away remember it as one small formula. 1 plus x raised to minus is nothing but 1 minus 2 times your x. So using that logic, what will happen is this minus 2 will come here. So this is your final formula. So acceleration due to gravity at a certain height. No need to write this for your exam. This is only for your understanding. Write somewhere this height and keep. So acceleration due to gravity of any object at a certain height is this. Now when the object is at a height. Now the second next derivation is, suppose if it is inside the earth at a depth. Diagram will be, now the outer one will be earth. So one more will draw at this particular depth now. This is the center of the earth. Obviously this is the radius, or basically it's the total radius here. Okay, it will look messy, no? I draw this side on. From here to here is also r only. I have not drawn it on the same line because it will be confusing. So this is r means from here to here also is r. You should know that. So this will consider point A. This is at point B. This is capital M for the Earth. So just put a dotted line. If this whole distance is r and this much is d, how much will be this distance? Can anyone tell me? This full line is the radius of the Earth, that is r. This much is, I know, is d. So what will be this length from here to here? From center.
R minus AD.
R
R
minus
minus
D.
yes. So this will be r minus d. Okay, so this is the diagram. So this is anyways first reference point is on the surface of the Earth. In the previous proof we were checking at a height. So point B was at a height. This is at certain depth. So point B is at a depth. Now write the same thing. Consider spherical or let whichever let Earth be spherical body of mass m and radius capital R. Then let m be mass of small body. Now at point A. So if m is at point A, small mass m, okay. If m is at point A on the surface of the Earth, acceleration due to gravity g is nothing but same like previous. First equation is same. Capital R. From here to here, you know that distance is r. Now second one at point B. If the mass m is at point B at a depth of d, at a depth d from the surface of the Earth, then acceleration due to gravity gd. Now I'll use d. For height I'll use h. Now what is the distance from here to here? R minus t. Okay. Now this something called as densities will come up because now it is inside the earth. So definitely it's not an open space. It's a packed space. So it depends on how much dense also the surface here the earth is. So this derivation will be in terms of densities for both at the surface and over here. Okay, so you can mark this as equation 2. Okay, so for this one, no depth, this mass we can just put as dash and keep. I'll explain what it will be. Just put a dash like this and keep. Yeah. One was at the surface at point A we saw, one is this. Now let rho be the density of the material of the earth. Now material will come up because it depends what is there inside the earth. Because it depends on how dense it is. There will be certain places where there is water, no? So not necessary acceleration of that particular mass in water might be same as inside a rock or inside a simple sand. Okay, so it depends on which part of the earth under depth it is, what kind of material it is surrounded with. So that's why we have to deal it with densities now. Sometimes it could be in the water part, it could be under the rock. So every place that this effect will be different. So let rho be the density of the material of the earth at which this particular point is present. So we know that density formula, nothing but mass upon volume. So rho will be density formula. This is rho. Mass is nothing but m. So volume is volume of the sphere. Okay, this is for point A we are doing. Just write here for point A. So point A means here I am. So this is a full circle. So how much will be the volume? Volume of a sphere formula. So volume of the earth. So that will be 4 by 3 pi r cube. This is the volume of the sphere formula. So we have assumed anyways the earth is spherical. So that's why 4 by 3 pi r cube. So what we'll do, m you keep here, rest of the things you take on the other side. So everything I'm taking this side. So it will be 4 by 3 pi r cube into rho equals to m. So mark this as equation 3. Okay. So now put this value of equation 3 in equation 1. Put this value of m in equation 1. What was the equation 1? G was So put this m over here. So what will happen? R square and this will cancel. Out of 3, 2 will get cancelled. So G is nothing but 4 upon 3 pi R rho. G I'm just writing here. Mark this as equation 4. Okay. Now at point B, again you write density is nothing but mass upon volume. Now we will not use the same m because why? We can't use the same letters because here the density might be different and here the density might be different. No, at point A and point B, Earth will not have the same density. Here it might be some soft this sand. Here it must be a hard rock. So it doesn't matter. This it might not remain the same. So we cannot use the same thing over here for mass and volume. What we'll do, we'll use some of the letters. That's why I've used that letter dash. So you can use m dash. Okay, based on the different mass here, and then volume also will use v dash. So that point B, it's of this part. So this is m dash. What will be the volume over here at this point? This sphere, okay? Second sphere. This was the full sphere, but now we are calculating density over here, so it will be of this sphere. So 4 by 3 pi. Now which r will have to take? R minus d. Okay, this I am calculating for this sphere. So what is this radius of this? We have already seen it's nothing but r minus d. So now keep m dash here only. Take rest of the things this side. Mark this as equation 5. Now that's why I used m dash over there for equation 3. Put value of m dash from equation 5 in equation 3 because it was for this circle, mass of this circle. So what is the equation 3? Equation 3 was now put this value over here. This entire thing, substitute it here. So it's into 4 by 3 r minus. Now again, same like this will cancel. Now G 4/3 by r minus d. I just wrote it here. So equation number 6 again. Now what you do? Divide equation 6 divide equation 6 by equation 4. So this and this will cancel. So what remains is r minus d upon r. Now just separate that r for both the terms. So 1. And just take this g off. Because why? We have to calculate acceleration due to gravity at depth. So this I don't want, take it on the other side. Basically, so this is the answer. We'll solve some problem. Wait. Okay, first question. This is a problem based on the starting first formula. Question 1. Mass of the planet Jupiter is 1.9 into 10 raised to 27 kg. And that of Sun is 1.99 into 10 raised to 30 kg. The mean distance is approximate average distance because no one will sit and actually measure it like proper, like exact value, approximate value, that is the mean distance, because they keep on moving also around. So the mean will be like an average. The distance of the Jupiter from the Sun is 7.8 into 10 raised to 11 meter. Calculate the gravitational force which the Sun exerts on Jupiter, assuming Jupiter moves in circular orbits around the sun. Also find the velocity. Copy the question. Mass of the planet Jupiter is 1.9. Okay. So basically what all is, they are like two bodies. One body is the Jupiter, the other body is Sun. Their masses have been given to the two bodies. M1 or M of Jupiter you can use. So that will be mass of Sun distance, that is R you have to assume. Gravitational force has been asked. Constant is fixed. Gravitational constant will be fixed. I've already given you the value of gravitational constant. That is, even if they don't give, you have to know 6.67 into 10 raised to minus 11. Now you know the formula. Starting only I had given force of attraction between any two bodies. And also what is V has been asked. So F is nothing but G, M1, M2. So I can just use Mj and Ms between the Jupiter and the Sun upon R square. So just substitute the values. 6.67 into 10 raised to minus 11 into mg 1.9 into 10 raised to 27, 1.99 into 10 raised to 30 upon 7.8 into 10 raised to 11 the whole square. Okay, what happens is all the powers you have to bring together. First, before that, you can just square this up. This you have to multiply. All the powers I'm writing together. Not required as such, you can directly add also. You can skip this step. Now squaring. So basically you have to square both the terms. So this would anyways give you 7.8. It will give you approximately 60.84 after squaring. Now this. Don't square this 11 and write it as 121. It will be wrong. Whenever you are squaring a power, it basically gets multiplied. Only thing is like you have to double it. So this will be anyways 10 raised to 22. Then do this calculation part separately. And this power, this will be 6 84. All the powers I'm writing together. 11. The numerators you have to add. If any denominator, it will go up and become minus. Which will become go on top and become minus 20. You can remove the signs basically here like this. Two of them will go. So it will be 6084 and 667. If you are removing two decimal places here, you have to remove two here. So you should be getting just to this 0.41 into 10 raised to check total you add. So
24.
yeah, 24 into 10 raised to 24 newtons force, no? So unit will be newton. Also, it's been asked to calculate the velocity. Is nothing related to this chapter. It's based on the previous one. If the sun and this fellow is moving in a circular orbit, okay, if Jupiter is moving in a circular orbit around the sun, definitely it's a circular path. So whenever we have to calculate velocities in circular path, we know that it is nothing but centripetal one. Okay, the centripetal velocity we have to use formula. So that is centripetal force has been given as the force between them mv square upon r. So this is the formula to be used. This force is same thing which we have calculated just now. M, this M now there's only one M. So whether it is Jupiter or this, it will be of the Jupiter because velocity we are calculating of the Jupiter. Which is sun is not revolving. Sun is at its own place. So what is revolving, moving? So Jupiter is moving. So obviously we have to whatever is moving only will have a velocity. This is moving. So the velocity of the Jupiter we are calculating. So this will be mass of the Jupiter. One point, no, 7.8 into 10 raised to 11. Okay. So take rest of this. This is enough. 0.4 10 raised to 24 into this will go up 7.8 into 10 raised to 11 upon this will come down and v square will remain here. If you calculate this, it will be 1.70 into 10 raised to 8. Then root of 1.7. Now whenever you are taking a root sign, what will happen? It's like root means it will become half. Squared you have done double. Square root means it will become half. So this is basically square root of 1 into 10 raised to 4 it will. So it's like square root of 16 approximately. Okay, I'm just assuming square root of 16 is 4. So 17, this long method, suppose if I use 17, 4, 4 plus 16. 1, that will be 0, 4 plus 4 is 8, again 0, 2 you have to take down, no? So 80 ones are approximately 0.41 into 10 raised to 4 will be your V. Meters per second, no? Next one, next question. A sphere of mass 40 kg is being attracted by another sphere of mass 80 kg with a force equal to 1.4 of the milligram. Weight with their centers 30 centimeter apart. Calculate value of G. A sphere of mass 40 kg is been attracted by another sphere of mass. So M1 is basically 40. Other one is 80. Now, there's a force which is equal to 1/4 of a milligram. Now, milligram means what? Based on, now this is standard unit we use, that is kgs. So, milligrams. So, first of all, we know that 1000 grams will make 1 kg. And then milli means 3 times 10 raised to minus. So total there will be 6 of them, 6 zeros to reach kgs. It's like 1 gram is 10 raised to minus 3 kg. Again 1 milligram will be again 10 raised to minus 3 into 10 raised to minus 3. So total would be 10 raised to minus 6. So milligram value would be 10 raised to minus 6. Okay. And then center distance R is 30 centimeter. We want it in meters. So obviously we have to convert it into meters. So we have to divide by 100. Because 100 centimeter will make 1 meter. and then you substitute in the same formula and calculate. F will be G, we have to calculate. M1 is 40. This will go up, it will become 0.09. This will come down. Right, like this. This all will come down, and G I'm keeping here. Then calculate and write your answer. Next one, the centers of two identical spheres are 1 meter apart. If the gravitational force, I'm just writing as GF, okay? Gravitational force between the spheres be 1.0 Newton. It's basically 1 Newton, huh? 1.0 is 1. Then what is the mass of each sphere? Sometimes they give G is 6.67 into 10 raised to minus 7. In this problem, G value is already given. Otherwise, you have to look out in the question paper, no? Starting only they give all kinds of values, no? Under that, sometimes they give this value of G. Starting of the question paper. Now, you have to find the mass of the bodies. F is given as 1 Newton. G we know is 6.67 into 10 raised to distance 1 meter apart. Now, here see, we cannot calculate two quantities at the same time in the same formula. We know this is the formula. F is what? G times M1 M2 upon R square. Two things we cannot find, but look out for this. Two identical spheres. Identical means same one, similar. So obviously identical means you have to assume both will be equal. So M1 also will be equals to M, and M2 also will be equals to M. Whatever is the mass of first body is equal to the second, because they have mentioned identical spheres. So now you substitute. F is 1 Newton, G is 6.67 into 10 raised to minus 11. This is M, which we don't know. This is also M, 1 square. Now it will be like this. This whole term will come down. Now I want to take square root of this because m is square root of this particular thing. Now we cannot write it as minus 11 by 2 m cube. I told you whenever you're taking square root, it will become half. Okay, but it's an odd number, so we can try to make it even. What we'll do is, if I want to make it even, I can just shift one decimal point this side. Okay, so it's like 6.67 into 10 raised to minus 11. I'm multiplying it by minus 1 so that it becomes suppose minus 12. Basically, I'm dividing also by minus 1. 10 raised to minus 1 is nothing but 0.1. Which I'm balancing like this. So this will become 10 raised to minus 12 upon 10 raised to minus 1. So it's basically this 1 point I'm shifting this side, dividing by 10 raised to minus 1. Because it's nothing but 0.1. So if I'm shifting 1 point this side, then this fellow is also 1 point this side. Minus 12. And then this fellow will come out as minus 6. And then you have to find basically square root of 66.7. Something 8 point some values in, because 8 8 is 64, no? Approximately 1 upon 8 point something you will get into 10 raised to minus 6. So that will be, take it on top and it will become plus 6. And answer will be in terms of kgs. Unit will be kg. Okay. This question you all can try then. Last one. Give you the question and you all solve. Directly I'm giving shortcut. There are spheres, one of 40 kg, the other one is 60 kg. Okay. Placed at a distance of 0.9 meters and force is 0.02 mg. Now this is milligrams. Milligram means I have to convert it into normal F. So milli means 10 raised to minus 3. So it will be basically 0.02 into 10 raised to minus 3 of today. Okay, and rest same thing. M1 is 40, M2 is 60, R will be 0.9 and F is 0.02 into 10 raised to minus 3. You have to calculate these. Next class then I'll solve based on that height and depth problem. The ones which they have derived those formulae based on that. So stop here.